Hello, this is simply about networking protocols, and today we're talking about frame processing procedure. There is no specific specification that could explain all the levels of the packet processing. This is mixed from different specifications. Frame processing, this is a set of operations that device make with received packet to decide where this packet should be sent to and in which form. In other words, if you remember, we'll already talk about that. Set of configuration of the device defines the set of rules that in combination of values in frames fields allows the device to select the port for ports for frame address and prepare frame to be processed by next device in the network. In general, order of operations on the frame equals to order of levels of OSI model. On each level of the OSI model, only fields related to this level are counts. So in general, system knows values of all valuable, let's say it, fields in the frame, but some of them have meaning and some of them have just value. Schematically, we can display it like that. So measurable value means that system see that this is some hexadecimal number in this field, and it can operate with it. Like if destination IP is 10.10.10.10, then do something. But for example, on level 2, this destination IP 10.10.10.10 has nothing to tell to the system. It's just a number. And on each level, meaningful always fields related to this level. For example, on level 2, this is destination source MAC, VLAN type fields, and Ether type. On level 3, this is IP header and some IP information. On level 4, this is TCP UDP destination source ports and stuff like that, and high is higher. And level 1, well, for verification of the switches and routers, you most likely will not have much to do with level 1 fields, so mostly it will be ignored like it was processed. On level 2, most valuable fields are destination source MAC and Ether type. And here, if destination MAC equals to MAC of our device, we understand that this frame should be processed by our device in a little bit more complex way than just simple switching bridging. And each frame on receive, on ingress, will pass all the levels of the OSI model till the highest one, where final processing will be done. And then if decision was to egress this packet from another port, on egress port, schematically, you can imagine it as packet going down from the maximum level it was processed on till level 1. By the red line, I selected the L2 switching bridging because this is basic operation. And if this device that you are working with is not something very specific, for example, some routers doesn't have L2 at all, they operate only on L3 level and cannot switch and bridge packets, they doesn't expect to receive L2 packets at all. Then those specific routers are something different. They are working with L3 only. But most devices have combination of the switching and routing, and switching will be the base operation. So each packet that switch router has received should be processed on L2 and might be processed on L3 and 4. And set of values and meaning of these values of L2 level signal system, should this frame be up for processing on L3, then basing on fields in L3 layer to L4 and so on and so forth, or basic switching routing is fine and nothing else should be done. And main condition that signals to the system that packet should be processed, not just switched, but processed somehow, including moving it to the L3 level, L4 level, and so on. This is when destination MAC equals to this device MAC. So you should remember this condition, because this is one of the basic condition, for example, for the routing. In general, that's simple. Thank you. Have a great day.